is to eh, okay, now officially started. Thank you, Loni. Again, welcome, guys, and this is just a continuation of the series that we already started. And the purpose for this is to enforce our Linux understanding, right? How the computer tool that we use as a whole, how does it work, right? And that's what we want to do. And we'll continue already with the workshop that already is. And last time we had spoken about uh, how the Linux system works, right? Basically. So the way the role of the Linux kernel in the operating system, okay, okay, Lonnie, no problem. The role of the Linux kernel in the operating system, we did not really talk about user space and kernel space, right? But we did talk about the fact that the one who schedule processes in the system is the Linux kernel. The one who manages memory is the Linux kernel. It's a memory manager. It's also a subsystem of the input output system, right? So already established last time that the entire software system, it's just an input and also output system, right? The part that does the processing is the hardware system, not so. So with that in mind, there has to be a facilitator to get input, do process, and get output, right? That's literally how a basic computer system works. So it's the Linux system that does that. And we already established from the first day that the Linux system primarily is just a file system because everything on Linux is a file system. And of course, with file system, they have to talk about networking so that one part of the file system can discover another part and that kind of stuff. So what we are going to do today literally is just to play with the Linux, and I don't have I cannot see you guys in the meeting, right? Because I'm looking at blah 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 this. So again, this is not a lecture. This is Chida, this is for you, right? So we have to do this together. I will appreciate if you can share your screen so that we see what you're doing, right? And this is not a lecture, it's for us to talk. So we'll do stuff, and you literally ask me what these stuffs are, and I will explain and that kind of stuff. This is the purpose of workshop. Workshops are for digesting knowledge. It's not again for you to read about this, like that kind of stuff. So it's more of practicals. Unfortunately, Linux is a very boring stuff. So yeah. So what we are going to do, we will just play around it. And the first thing that we are going to play, what I'm going before we play, I'm going to say that Linux follows a monolithic kernel model. So there are different ways of programming a kernel, right? And Linux follows the monolithic model, right? So most of its core functionality runs on the same privileged memory space. Primarily means that there is just one memory space that it gets everything from, right? So there is something called the micro kernels, right? That you try to offload services into user space, and then Linux keep all the core logic, something like that, right? But Linux is monolithic for your own understanding, right? So the scheduler, the memory management, the device drivers, they are in the kernel. All of them are just there. So most of what we interact with daily, the terminal, the shares, the editor, whatever stuff, right? They leave. Okay, now that sounds confusing. So there is actually a user space and then there's a system space. It's a monolithic kernel model, right? So the kernel, no, the terminal, the shell, the editors, those kind of stuff, they are in the user space. So those things that you're installing, they are in the user space. But you also have now like a system space where everything about the system core, right, it's inside of it, right? Tell me if this confuses you. Uh,
Yes, sir.
mm,
Yeah, yes, sir, it's a bit confusing.
what is confusing about it?
So you talked of user space and system space, like, and I don't really know the difference between both of them.
Yes, there is the user space. This is the user space for the kernel module, right? Boom. So most of the things that you are installing, they are here. Key users, la la la, la la la. You see the bus, you know about the bus, the net, the mount, memory information. So this is the user space basically, right? And you also have like
Yes,
the system space, right? And I mean, this is not really, I've not gone real deep into this, so I cannot tell you like the difference between this one and this one, right? But this is, see, for example, the
yes, sir.
hypervisor, right? So if you want to run stuff like, if this is the hypervisor, by the way, so it means that with this hypervisor, it means that there is a possibility for my PC to do virtualization, so I can do virtual PCs, virtual machines, those kind of stuff. You see the kernel folder itself, you have stuff about the power, right? So these are all of these things are stuff that are dealing directly with the hardware. That's what I'm going to say, right? And then this stuff are stuff that, yeah, concerns the user directly, right? So whatever you, the user, have to configure in order for the kernel to perform any of its function, this is where it lives. So whatever the system has to call, right, without the intervention of the user in order to perform a kernel function, this is where they are. Literally, that's what I'm talking about. Is that understandable?
Yes, sir.
Wonderful. So,
And you said,
since we are
please,
talking about,
so the user space, does the user space, you said the user space concerns most of the things that we install in our machines, right?
no, when you put it like that, it will be a little bit misleading. It concerns most of the things that we can configure. For example, we have a terminal here, not so, right?
Yes, sir.
So
Yes, sir.
whatever you see here, whatever configuration you can make here, right? For example, I am using ZSH, right? So I can change to bash, right? Right?
Yes, sir.
The ability for me to switch from
Yes, sir.
bash to ZSH, right? For example, depends on what is written here, right? All of this stuff are literally in here like that. You get the point? It means that
Yes, sir.
there are these things are programs, but you have the ability to influence the program, right? For example, if I come back here, you'll see things like swap, because you can it's something that the user can configure, right? You have things like a CPU information, because you can, if you come here, if I come here, system monitor, what, you cannot see it, right?
No,
No.
sir, I can't.
Yeah. Okay, that's fine. It's because I don't have a screen and my PC is running low. Okay, that's fine. So you have this stuff that are here. You can change how they look like, right? Your terminals, right? Your
Yes,
terminal
sir.
exists. What happens when you when you run a command, for example, when you do this, not so. What are you
Yes, sir.
actually doing? You are giving an instruction to the computer system it as a whole. This part that we are on right now is uh, the part that we are on right now is the software system, right? So the software system takes this instruction where, okay, I'm going to do this. This is better. Let's do proper engineering. Hello, Sinke. Do you have draw IO? Yup. Draw dot IO. Wonderful, wonderful. King Solomon, hashless love. Okay. So what am I going to do? I'm going to go back here and say share. Really? Mm-hmm. Wonderful. Can you see um, my drawing?
Yes, sir, I can see it.
I'll open a different page. Um, how do you put input here? I'm going to call this part, whatever this is, right? We have three systems that we are dealing with here. Okay, wonderful. This is your software system. In this software system, you have an intermediary, right?
Yes, sir.
This is what we are calling your kernel. So I'm going to make this better by doing this. Wonderful. Mhm. This is what we call a kernel. And then you literally have like your hardware stuff right there. So you have this stuff here called your hardware, and all of this look really, really awkward. Wonderful. Okay, now I see what's wrong. Wonderful. So you have your hardware system here. So the basic computer system requires an input, right?
Yes, sir.
So I'm going to put an input here, right? The basic computer system requires an input, and this is where the input string is coming from. Now, mhm, this is not the input. So I'm going to, wonderful. So this is your input here, and then you have the output that goes back to you here. Not so. So you have the output. So you can duplicate this and say here that this is your input, and this is the input here, and you can have this here again going back to the kernel as your output, right? This is what a basic computer system looks like. Not so. And then inside of it here, we are going to do this. uh, Wonderful. I'm just going to give it a small color, whatever this color is. I don't like this. Okay, this one looks better. So this is what you have, and I'm going to try and do a small line here, and then I'm going to break it literally. Why is it doing this? What the heck is this? Okay, this is fine. That's horrible. I'll try and leave it here. So this is what I want to picture out for you, that um When you are doing this stuff, when you are interacting with the computer system, which is this big box here, right? This is your computer system. We can do better with these columns. This is your entire computer system, this orange box. What happens is that the computer is built in such a way where that you have your hardware, this component, and you have your software system, this component. And in between them, you have this kernel, not so, which is acting as intermediary. Why is it acting? Why does it have to act as an intermediary? Because the input that is being sent, right? The input is coming from the software system that goes to the hardware system. The hardware system has to process it and give it back an output. This input is written in human format, not so. So I'm going to draw a very nice box again here and call it. It doesn't even matter because it's inside this box. That's bad. So, but I'm going to send this one behind. Wonderful. So this stuff here, the input in this blue part is in human form, but then the what this one is receiving, right? Go back
Yes, sir.
and then go back and then change this to something else. What is being received in here is in the form of zeros and one, right? You get that point, not so?
Yes, sir, I get it.
Wonderful. So you have um, some program files. There's some program files that are here, and I'm going to call them. Where is it? So this is the slush proc part, and this thing is really horrible because it's so small. And you can make it a wonderful. You have this slash, this program in this part that is able to understand what the humans are doing here. So it is programmed to understand what the humans are doing in here, right? But it is interacting with this kernel. I'll push this up to show that it's interactions with the kernel, right? So whatever you do here, whatever you're doing in this system, you have the files that are written in here that are capable of understanding that input that you are passing. And this part is being interpreted by the kernel to know exactly what to display here, right? But then you have this other part, right, which is also another program, but it is designed to work with the hardware format of this part. Does this make any sense to you now?
Yes, sir. It's clear.
It's clear.
Yes, sir.
Wonderful. So that's basically what is there. So the thing that you should understand is that if I go to my IntelliJ and say that maybe you see there are colors here, right, that are being
Yes, sir.
printed out to me. For example, in my terminal, I'm able to do that because I this the files that the program that is written in here can be interpreted by the kernel That is the desire, that is what I desire to see in here, for example. And the kernel will be able to do that for me. But at the same time, the kernel also has configuration in here that this part can send stuff in here to show that, okay, this stuff, that kind of thing. So this part is concerned with the format of the hardware system, while this part is concerned with the format of the software system, because it is the user that uses the software system. This is very high level, but for your own understanding. Does it make sense now?
Yes,
Makes
so
sense.
like the kernel is the intermediate between the software system and the hardware.
Yes, that's basically what the kernel is doing. So, yeah, the kernel has these two files that interprets what the human instructions that are coming from this part, right, and
Yes,
puts
sir.
them in a format that the hardware can understand, produces an output, and give it back to the kernel. The kernel will not transform it into something that the humans can understand and it will display here. Basically, that's what's going on. Very high level.
Okay.
Understood.
Yes, I've understood it.
Wonderful. So, where are we again? So, now that we have that out of the way, we can continue. So, the first thing, where am I really? The first thing that we can do here is we can check, because we are dealing with a kernel. Always you want to get information about what you're dealing with, right? So, well, this is the command, the Linux command that gives you information about stuff in the kernel, right? So, if you want to know all the information about, so print certain system information with options, no, let's go to the, okay, that's it. System information basically. It prints all information in the following order: kernel, node, kernel release, kernel, processor, hardware, operating system. So literally, if you want to, you can use this command to know everything. I'm running a Linux system. This is my host name. This is my kernel version. And this is the build, la 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 la, right? And we're going to interpret this. So first thing, we just needed to always check the version. Always. Whenever you're dealing with any package on Linux, the first thing you check the version, right? And this will just show you the version of the current kernel, the kernel that is currently running. And so now that I know, I mean, I already knew, but I'm just showing. If it was in a different system like this one, of course, I need to also check, for example. So you can run this along with me. The next thing that we really want to do here is we can see the build information about the kernel. Again, the kernel is a, today is really horrible. I cannot share on my screen. Okay, the kernel is a program, right? And it's available on GitHub. So you can find it there. So if you want to see the information about the kernel, you can literally put it like this. Again, do you see the file that we are using? Does it make sense to you to see this file from here? I can come to this system. I like the system better and I can do this. because he can do this. Are you is he with me? Okay, Marivon, welcome. Mm-hmm. Chida is no longer there. Okay.
Thank you, sir.
Did you just join?
Please, can you get me network? Huh? Jesus.
Yes, I can hear you just fine. I can hear you just fine. Okay. So we have this stuff like this that we can use to see the kernel build information. You notice that when we ran this command, we saw, sorry, we saw almost the same information, really. But here we have the kernel version, la, 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 la. This one was the host name, and this one is more generic to the system, right? But it is this one that is about the kernel. And Marivon, are you with me? Do I need to rephrase or restart or fill you in about something? Okay, guys are muted. So again, this is a discussion, and then you guys should always talk what I'm saying. Oh, you guys should always talk with me again because I cannot see the screen. So if you leave or come back, I'll not notice. I should not be in the call alone. But I'll be looking into it to make sure that yeah. So if I've been talking alone and you need me to rephrase on something, you can let me know. Right. So I was talking about the fact that we can. Yeah, somebody says something.
Yes, we had a little light issue here, so the network
Sorry about
went.
that. Okay. I was saying that we can view the
Yes.
kernel information, right? From the diagram that we drew last time, right? We saw that the stuff about the kernel that concerns the user is stored in la 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 this folder, right? So if you want to see the kernel build information inside this folder, then we are going to go inside this file called the version. So there's version signature, but we want to see the version. So this will give us the information about the build, about the kernel build information, and we can interpret this right very closely. This is a Linux system. We are running version 68083 generic. And what does this mean? This 680 is the main line of the kernel version. So this is what we are currently running, version 6.8.0, right? And this 83 is the patch level. Why is this important to know? It is important to know this because whenever you have like security or you're working in a security team or you'll be working with a security team, then they may complain that or they may send you info that or communicate with you that this particular version has a patch that hackers have infiltrated. So you need to either use the same version but with a different patch, that kind of stuff, right? And super important, this patch simply means that this is the 83rd revision of the kernel version. So whenever they do this stuff, they revise it to correct bugs, to correct things like security fixes, mostly important, right? And so they do it many times, and this is the 83rd time that they have done it for this particular version. It means that they have been correcting things on this version 83 times so far. That's what it means, right? And you have this generic. Generic here means that this is a general, that this is meant for this is a kernel build that is meant for general purpose. So it's, if you were running an embedded system, you don't want to run this version, this, you don't want to have this build version in your embedded system, because you can use another build version called low latency, right? Something like that. There are others like real time, many different flavors that you can get. But yep, so this is what this means. And you simply have this stuff here like the build, right? And this build Z is the automated daemon that is used by Ubuntu, right? So this is telling you the daemon that is being used by Ubuntu, not so. And this one is giving you a lot of information about where the server, the build server is, not so. From the little experience I have here, this is saying that the server where this build version is running on is in London, in the UK, that kind of stuff. Important to know this too, because, well, if you have a specific task in mind, right? And yeah, so far this one here, anything that starts, this one here tells you mostly about the compiler. So GCC, there is GNU here, and then there's GCC. Or honestly, I know graphic. Wait, what's GNU? You guys know about GNU? You've been studying Linux, meaning no full meaning. Okay, not the. Anyways, let's not get into that. But this GCC means what does it mean again? The GNU, really forgotten. Doesn't matter. Forgotten. Yeah, it's not coming to my head. But it's just telling you about the compiler. This is just giving you about information about the compiler. What the version there is version 12 really. The version 12.3 la. So that's the compiler that they are using, that kind of thing. And you have some other information and stuff. But yeah, it's how you literally read the build version of the kernel. Why is this important? If you need to build a kernel yourself sometime, if you need to do, if you're doing Linux administration, or you will be doing Linux administration, then you may need to do this kind of task sometime, because if you extend the functionality of your kernel, then you have to build it again before you have it right. That kind of stuff. So, yep. So, guys, this is why it's important to have this kind of things. Any question about this ugly looking thing? Any question from anybody? Am I still the only person in the call? No.
So please,
Mm-hmm.
concerning the generic, you said it's when the Linux system is made for general use,
Mm-hmm.
so it can be for private, like for private use only.
No, not private use. What is a generic use computer? So, for example, the operating systems that are running in the fridge, it's not the same operating system that are running on your PC, right? You can imagine that it's not the same, right?
Yes, sir.
Wonderful. Yeah, that's because the ones running on your fridge, it's not generic, right? It's not a general use something. It's very specific, and I can imagine that it has like specific functionality. General use case means that you can't use it to demo different stuff. So I can use this for microcontrollers, right? I can use this to program microcontrollers. It's going to work because I have the functionalities to do that. I can't use this to do what else. I don't cannot. Nothing can come to my head. Right, but general use case means that for many specific aspects, you can demo many different kind of specific aspect using it. That's all. So the the video doorbells, those things will be using microcontrollers, for example. What can I use? I'll use the one they use Internet of Things, right? For example,
Yes.
they'll be using specific stuff to do it. The operating system running in the car, for example, cannot be the same as the one running here on the Linux, right?
Yes, sir.
You understand? Yeah. So that's the point. Not that there is like a private stuff for it. There's no kind of private stuff for that.
Okay, so understood.
Wonderful. So, I already ran this command. Wonderful. So, the next kind of thing that we'll see here, which does not look great, is this. So, are you guys running these commands with me? I mean, that's what we have to be doing and discussing. I'll prefer that you run it. So, I'll stop sharing my screen, and somebody among you should share their screen. Excuse me. And then I'll give you the commands. Literally, I have them, some of them in my head, and then we'll simply discuss about it. Who is sharing? Let Marivon share her screen. Oh, Marivon, are you volunteering to share your screen?
Go to my terminal. I'll just have to switch to my laptop.
Mm-hmm. Okay, wonderful. So we can interpret this, right? I mean, you can uh make it bigger on your side. It's kind of smaller on the side. Wonderful. That's perfect. So this is what is this? What is all this information? This is the user programs that are making system calls, right? Uh-huh. It's user. So, like we were saying, like we put in this in where did you do that? Oh, okay, we did it here. We did it on this diagram. I'll steal the screen sharing because I know that some people were not here. Just to show you guys what we talked about sometime earlier. Where am I? I have so many tabs open. Okay, wonderful. So, like we said earlier, right? The computer system is a very simple system at the highest level. You have input from a human being, you have um, an intermediary that converts that input to what the computer can understand, and then you have the hardware system that will digest or process that information, that input, and give back that input to what an intermediary that will transform it to an output that the human being can understand. Literally, that's the computer system for you at highest level. And when we were looking at the last command before this one that we are running now, we saw that the kernel build has a compiler version in it. And why is that important? Because it is that compiler part that is necessary, that is used to, it receives a human input and then transforms it into something that the hardware system can understand it, and vice versa, right? That's why we have the compiler linked with the kernel. Of course, you cannot talk about the kernel without the compiler. The compiler is a component of the kernel build. So, with respect to what Marivon is sharing, this present command, you have you have programs here. I'm not good at this draw IO honestly, but you have here, you have these programs here that want to talk to the hardware. Not so. If you send an input from your terminal, how does that input get get to be processed by your hardware? Your terminal has to do a system call, right? A system call means that you'll be asking the kernel, hey kernel, I have this thing that I want the hardware system to do for me, right? So come in and take it from the terminal. That is the system call. This interface right here that I'm clicking on, this interface represents every application or program that you can possibly run, right? It has all the programs. So which specific ones are you talking about? So the command, Marivon, you can steal the screen sharing again. I'm always lost where this stuff is. Yeah, okay, perfect. We can see your screen. So the command that Marivon has, no, that's not Marivon, Bonisam. The commander Bonisam has just run is informing us of all the programs. It's informing us of all the programs that are making a system call, right? They are making which all the programs that are running, go back here. All the programs here that are sending input or receiving output information from the hardware, all those programs that are currently doing that, that is what that command is sending. Who has not understood what I'm saying, or who is not understanding what I'm saying? Does it make sense, guys? Yes, please go on, my Bonasam. Can you guys hear me? Wonderful. Yes, please go on. Oh, mm-hmm. Okay. I guess nobody's saying anything.
Hello, sir.
Yes, go ahead.
Please, he's trying to connect his headset to ask the question.
Okay.
Yes, he said he didn't understand something. Like, he will ask it himself. Please.
Okay. In the meantime, I'll proceed, right? So, everything that you see there, the very first thing, okay, everything that you see there, right? The very first thing that you see is the fact that on Bonasam's stuff, we have this exec VE, right? And this exec VE, this is the first system call, right? And that is being made every new process that wants to be executed, not so. Every new process that wants to be executed literally has to make that call. So you see user USR bin ls. That is the program, literally the program that wants to talk, that wants to send. Um, that is the program that wants to send something to the system for processing, not so. And the zero at the end means that the program succeeded to make a system call. Mhm. Somebody's talking.
Also, I don't understand what
Okay. Are you guys in the same
that
place?
I was
Are you guys in the same place? Then you could use somebody's mic. Oh, okay. So, perfect. Let's continue. I can share my screen. I don't know which screen I'm sharing. They can I can do it for me. Literally.
Sir,
Yes.
this is Bonisam speaking.
Okay, wonderful. Yes, go ahead.
Yeah, as I was saying, you asked a question that if anybody understood what you said in the previous thing that you explained, so that we don't understand.
Yes, what did you not understand?
Um, I do not understand the part where you said that that the that the Ubuntu update store that is 6.8 zero then HTTP store.
What? What? Can you say that again?
That stuff that has to do with the HTTP,
83.
yeah, that has been updated HTTP times. So it's like
Oh, the patch. Yeah, I mean, that's something that we are going to discuss in the future. It's called release process, right? It's something called, it's a huge topic in the field of software engineering. It's called release process. How do you deliver your software products to for consumption, right? So you do them in what is called release. So when you have the first release, people use that version of the product and give you feedback that, hey, while we're using this, we're not able to use this feature, or while we're using this feature was breaking, or that kind of stuff. So when you fix those things from the feedback for that particular release, not so, you do what you they call, most people call it patch release, other people call it hot fix, whatever it's called, but for Ubuntu they clearly call it patch, right? It's a patch, so it means that they release a particular version of the build kernel, and then they received feedback. They have been receiving feedback. So the first time they received the feedback, they will release that particular version of the build kernel again, and then they'll note it with a patch version there one. So for our own, so the first time that they released it, so when you do this release the first time, this here is zero, not so, and then you just have all of this, and then this is zero. People use it and give you feedback, and the first time they give you feedback, you are maintaining all the features that are here, but you're correcting some of the things that are wrong with the features, not so. So you release this same version again, not so, but you change this number now to 1, to say that this is the first time you're correcting stuff from there. So this 83 means that since they released this stuff, they have had to correct things about this version 83 times, literally. Mhm.
Thank you.
Won- Wonderful. So back to this. So this command will show us all the programs that are making a system call. So the most, say this program ls just made a system call and it was successful, so we have 0, that kind of thing, right? And I don't like it like this because it's so wonderful. I prefer it like this. And you can see here there's another program that has this null stuff, and you even see this one, right? And these are memory allocation and architecture specific setup calls. So the setup, like the threading of the local storage and some other stuff which I don't have off head, right? And they do things like they normalize their normal initiation step for linking binary files, right? So these are system calls that link binary files. So if, for example, when you run ls, actually this is a file that you're executing. If this file needed another, or we can go here, needed another file, I'll not go there because it will be a little bit complex. Needed another binary file, but that they have a symbolic link, then you have this system call that will be made, right? I'll try and put everything now very high level. But of course, as you continue, you start your career, you are going to be get into specific case specific stuff. But you cannot even what's funny is they cannot get you into a case specific stuff if you don't know the high level. So unfortunately, this is how the process is, right? And we have other stuff here. For example, we have this stuff here, this open NAT, and This is the system call that says that we should open the current directory, that we want to read the current directory, right? So it's again, when you do ls, what are you doing? You're reading the files and folders of the current directory, and that's those kind of stuff. So what you should know about this command is that everything that is using the kernel to make a system call also, it can be shown to you using this command, right? So there are a lot of stuff here, but as you go on ahead, you will get to understand which one is used for what. Any question, guys?